You need to know the vocabulary to do well on this section. I'm going to have every one of these posted on the wall for you guys. Let's go through them one at a time, super quickly. Keep up. What is a quadratic function? Y equals x squared is a quadratic function. Anything with an x squared in it, actually anything with the highest exponent of 2 as an x squared in it, will be a quadratic function. Y equals 3x squared is a quadratic function. Y equals x squared is a quadratic function. Y equals negative x squared is a quadratic function. Y equals 3x squared minus 2x plus 5 is a quadratic function. Y equals x squared take away 7 is a quadratic function. Anything with an x squared is a quadratic function. Okay, let's move on. And a quadratic function, when you graph it, it's going to produce a parabola. And if you don't know what a parabola is, man, you got to start paying attention. A parabola is a U-shaped curve. It could be opening up. It could be opening down. It could be really wide, like that green one, or it could be really narrow, like that yellow one. So whenever you graph a quadratic function, anything with y equals x squared, it's going to produce a U-shaped curve. Okay. Now, we have a certain form, the way it's organized, and on this section, the form that we study is standard form. So what is standard form? Standard form is y equals ax squared plus bx plus c. This is something that you need to know. You need to be able to identify a, the number in front of x squared, b, the number in front of x, and c, the number without any x's. You need to know this. This is how it's organized. What does the word form mean? The way it's organized. This is the way it's organized, standard form. A in front of x squared, b in front of x, and c without an x. So once you know that, A, B, and C, you'll be able to find things like the vertex. But before we even talk about how to find the vertex, what the heck is a vertex? The vertex, it's going to be a coordinate. It's the most important point on your graph. It's either the maximum value or the minimum value. It's the maximum point or the minimum point, depending on if the parabola opens up or down. So I'm just going to draw a sketch, a quick parabola. Here's a parabola right there. It's opening up, right? What's the most important point? The most important point would be right here, this location. That's what you call the vertex. In this case, it's a minimum value. Or if your parabola would look like this, if it were opening down, then your most important point would be this one right here. That's the maximum value, right? From left to right, it's going down, 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 reaches the lowest point, then it goes back up. That lowest point is called the minimum. Or on this one, from left to right, it's going up, 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 reaches a maximum value, then it goes back down. That's called the maximum. That's a maximum vertex. Okay, I hope we get this. Maximum and minimum is something that you're going to see on the wall and something that you see on the quiz and test, right? The vertex is either a max or min, depending on the A value. If the A value is positive, if it's happy, then you have a parabola that looks like it's opening up, right? If the A value is sad, if it's negative, that means that if the A value is negative, that means that the parabola is opening down. That's simple, guys. If the A value is positive, then the parabola opens up, which means you have a minimum value. If the A value is negative, that means that the parabola is opening down, which means that you have a maximum value. Okay. What else? So now that you know what a vertex is, either the maximum value or the minimum value, the highest point or the lowest point, depending on if it opens up or down, we also need to be able to find that point without looking at the graph. And how would we do that? By knowing this formula. Okay, now again, the vertex is a location. It's a point on the graph. It's either the highest point or the lowest point of your U-shaped curve, depending on if it opens up or down. How do you find the vertex without looking at the graph? You memorize this formula, x equals negative b over 2 times a. And whenever you use this formula, please do this, negative parenthesis over 2 times parenthesis. Always do that. That way when you plug in your values, it'll be safer. You won't make a mistake. That will give you the vertex x value. And once you have the x value, all you have to do is plug it back into the x's to find the y value. So let's find the vertex of this quadratic trinomial that's in standard form. Okay, in order to do that, you need the formula x equals negative b over 2 times a, and also rewrite it with parentheses instead of the b and the a. Once you have it like that, identify the b. The b is negative 4, the a is negative 2. Plug in the -4 up on top, plug in the -2 right on the bottom, and then do the math. What is a minus minus? It changes to a plus plus. You have a +4 up on top. On the bottom, you have 2 times -2. That's a -4. So what is 4 divided by -4? That's a -1. What did we just find? We just found the x value. It says x equals -1, okay? X equals -1. That is your vertex x value. The -1 is the x value of your vertex. You still need the y. How do you do that? You plug it back in, right? You know that x equals -1. Plug in that -1 right there and right there, okay? So I recommend rewriting it. Y equals -2x squared minus 4x minus 3. Notice that instead of x's, I put parentheses. Why? So I could actually plug in the x value of -1 right there and right there. Doing the math, you could do it all in a calculator, or you could follow PEMDAS, exponents first. A -1 times itself is a +1. So you really have -2 times +1, and that is a -2. And then right here, you have a -4 times a -1. That's really a +4, and you could bring down that -3. You now have -2 plus 4 minus 3 from left to right. What is -2 plus 4? That's 2. And what is 2 minus 3? That is -1. Okay, so the y value, y equals -1. So the y value of your vertex is -1. So the vertex, the most important point, is at the location -1, -1. And we know it's opening down because the a value is negative. So that means that this is a maximum value. This is actually from me graphing it on Desmos. As you can see right here, the vertex is -1, -1. There's a vertex. It is a maximum value because it is opening down. I knew all that without even looking at the graph using the vertex formula. And also checking if A is positive or negative, because it being negative tells me that it opens down. So we know now how to find the vertex. Let's move on to domain and range. The domain are the x values of your graph. It doesn't matter what kind of graph it is, in this case parabolas. The domain of any parabola, in this case, are your x values, and the domain of any parabola is going to be x equals all real numbers. It doesn't matter if the parabola opens up or if it opens down, if it's wide or if it's narrow, the domain will be x equals all real numbers because it goes to the left and to the right forever. So at the beginning of this section, we graphed the easiest type of quadratic equation, y equals x squared, and we did it the old school way, plugging in numbers for x, pulling out answers for y. We plugged in 0, 0 squared is 0, so when you plug in 0, you get out of 0. It's important to note that when you plug in, you plug it into x. The x's are your inputs. The y's are your outputs, okay? And also, another word for inputs is the domain values, domain. And another word for outputs are your range values, range or your outputs. Anyway, we graphed y equals x squared by plugging in 0. 0 squared is 0. We got out the coordinate 0, 0. That's that dot right there. Plugged in a 1. 1 squared is 1. So plug in a 1, get out a 1. 1, 1 is that coordinate. 2, 4, 2, 4. 3, 9, 3, 9. We plugged in a 3. 3 squared gave us 9. So we were able to graph this guy. So here's the vertex. It's the lowest point. It's called the minimum value because it opens up. It's the lowest point. We also know that the domain values that we just talked about, the domain is x equals all real numbers. Okay, in this case, in any case, the domain is x equals all real numbers. And you could use that notation instead of writing out the words all real numbers. Why is that true? Because this parabola, the domain values are your x's. So when I say what are your x's of this graph, it looks like it only goes like from here to here, but it actually goes this way forever and that way forever. Like you could plug in, we plugged in a 3. 3 squared gave us 9. We could plug in a 4, but it would give us 16. So when you go to 4, you're at 16, you're off the graph. You can go to 5 and it'll be at 25 off the graph. You can go to 10 and 10 squared is 100, way off the graph, but it does exist. It would just exist way up there off this paper, off this graph, off this screen. So the domain, it does exist to the left and to the right forever. It's to understand it, it goes up forever, but it also goes out forever. So it does go to the left and to the right forever. That's why domain equals, or domain is x equals all real numbers. Now the range that we're about to talk about right now, the range are your y values. And this parabola does not exist up and down forever, right? It exists at a certain y value and above. So in this case, it exists at 0 and above. So y is greater than or equal to 0. In this case, y is greater than or equal to 0. But the reality is, the range, you could think of it this way. Just by knowing if your a value is positive, that means that you have a parabola that opens up, you know that the range is going to be at or above that certain value. So it's going to be y is greater than or equal to the y value of your vertex. If your a value is negative, that means that the parabola is opening down. That means it exists at this vertex and below. So that'd be y is less than or equal to the y value of your vertex. So I hope we understand domain and range. The domain are your x values and the range are your y values. The domain on any parabola, it doesn't matter if it's wide or narrow, opening up or opening down, the domain's x equals all real numbers. The range is either going to be at a certain y value and above if the parabola opens up, or at a certain y value and below if the parabola opens down. We also need to know axis of symmetry. What is the axis of symmetry? The axis of symmetry is the vertical line that passes right through the vertex, right? So in this first graph that this first parabola we ever did, the axis of symmetry is this green dotted line, and it passes right through the vertex, okay? And if we look at our poster here, the equation will be x equals the x value of your vertex. So if you could see your vertex and they ask you for the axis of symmetry equation, all you got to do is say x equals and whatever that x value of your vertex is. Now let's say you don't see it and they give you a quadratic equation, then use the vertex formula, because x equals negative b over 2a. That'll give you the x value of your vertex, and that's what you need. You need x equals the x value of your vertex. Anyway, an important thing to note about all these vocab words or vocab phrases is I underlined the word vertex and I underlined some other vocab phrases and words. Why? Because these underlined phrases and words all come from the vertex, right? In order for you to know the maximum or minimum value, you need to know the vertex. The vertex is your maximum or minimum. In order for you to know the axis of symmetry, you need to know the vertex x value. In order for you to know the range, you need to know your vertex y value. You see, the vertex is the highest or the lowest point, okay? And if you want the range, you're either at a certain y value and below, or at a certain y value and above, okay? If you want the axis of symmetry, you need the x value of your vertex. So once again, one last time. Axis of symmetry, you need the x value of your vertex. The range, you need the y value of your vertex. Okay, moving on. We still need y-intercept. The way to find the y-intercept of any equation is to simply set x equal to 0 and solve for y. A y-intercept is simply where the graph is going to cross the y-axis. And we learned this in semester 1. To find the y-intercept, set x equal to 0 and solve. So since it's a location, it's a coordinate, the x value is 0, you set x equal to 0, you plug in 0, you find out what y is, and that'll be the location, 0, comma, whatever that is. So let's say I asked you, find the y-intercept of this equation. All you got to do is set x equal to 0 and solve. So you rewrite this guy, y equals x squared minus 4 times x minus 4, and you plug in the 0 where your x's were at, and you'll see that 0 squared is 0, 4 times 0 is 0, 0 take away 0 is 0, and 0 take away 4 is negative 4. So 0, negative 4 is the y-intercept. What does that mean? That this parabola that opens up, because a value is positive, will cross the y-axis at 0, negative 4. And this is on Desmos. Let me show you. Here's my parabola. And as you can see, this parabola really does cross the y-axis right there at that y-intercept that we just found, 0, negative 4. Just to recap, axis of symmetry is the vertical line that passes right through the vertex. What is the vertex? It's the highest or lowest point, in this case the minimum value because it opens up, and that vertex happens to be the location 2, comma, negative 8, which means that the axis of symmetry is x equals the x value of your vertex, which happens to be 2. The domain of this graph or any parabola is x equals all real numbers, and the range, because it opens up, and even if you didn't see that, you know that the a value is positive, which means that it's opening up. That means that the range is going to be y has to be greater than or equal to a certain y value. Now visually you see it that it's at the lowest y value of -8 and above, so its y is greater than or equal to -8. Or like we just said, the range is dealing with the y value of the vertex, which would be y is greater than or equal to -8. So once again, just to reiterate, the axis symmetry comes from the x value of the vertex. The range comes from the y value of the vertex. Final details, we need to know how to work an input-output table. So if I told you graph this equation right here, you could use an input-output table and plug in a number like, let's say 1. And if I do plug in 1 and I did all this work, it would give me a 1 squared that's 1, 4 times 1 that's 4, with the minus 4. 1 take away 4 is -3. -3 minus 4 is -7. So 1, -7 is a point on the graph. So I could do all that work a bunch of times and get a bunch of coordinates and then graph my parabola. Or the better option would be to memorize the pattern 1, 1, 2, 4, 3, 9. This pattern can be used from the vertex if your a value is 1. And if your a value is not 1, all you got to do is modify it. Now, what do I mean by the pattern 1, 1, 2, 4, 3, 9 from the vertex? Let's go back to the graph that we were looking at right now. And we know that the a value is 1, right? The a value is 1 right here, which means we could use the pattern 1, 1, 2, 4, 3, 9 and not have to do any math. Here it is, 1, 1, 2, 4, 3, 9. That means that from the vertex right here, that location, which is 2, -8, you could go 1 over 1 up, 1 over 1 up, and you put a dot right there. Then you could go back to the vertex and go for the next part of the pattern, 2 over 4 up, 2 over 1, 2, 3, 4 up, and put a dot right there. And then you could go back to the vertex and go 3 over 9 up, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up here. And you could, of course, map those dots over to the other side of your axis of symmetry, and you'll have that perfect parabola without doing an input-output table. So please memorize the pattern 1, 1, 2, 4, 3, 9. That could be used when the a value equals 1. Because the alternative is to actually plug in 1 to get out a -7. And imagine that. I mean, that's barely one coordinate, 1, -7. See, we got that blue dot so easy without doing any math. So memorize the pattern. And last but not least, what if you don't have an a value of 1? What if your a value is like 1/2? Then you would have to modify your pattern, the outputs of your pattern, by that new a value of 1/2. So like, let's say a was 1/2. Then here are your original inputs of your pattern, outputs of your pattern, and you'd have to multiply each of the outputs. The 1, multiply it by 1/2. The 4, multiply it by 1/2. The 9, multiply it by 1/2. Giving you a new output of 1/2, of 2, and of 4.5. Let's see how that looks like, or how that plays out on a graph. So let's say we were graphing this equation right here. I would use the formula x equals -b over 2 times a to find the vertex. And let me just tell you, I already did it, and it gave me a -2, 2, okay? I know that it opens up because the a value is positive, which means that if it does open up, I already know the range. The range is going to be y is greater than or equal to, because it's opening up, to the y value of the vertex, which would be 2. The axis of symmetry will be x equals the x value of your vertex, -2. The domain is going to be x equals all real numbers, but we want to be able to modify the pattern according to this new a value of 1/2. So the original pattern from the vertex was 1, 1, 2, 4, 3, 9. However, we need to multiply the outputs by the new a value of 1/2. Okay, 1/2, 1/2. So instead of 1 over 1 up, it's going to be 1 over with the new output of 0.5 up, or halfway up. Instead of 2 over from the vertex and 4 up, it's going to be 2 over and 2 up. It's instead of 3 over and 9 up from the vertex, it's going to be 3 over and 4.5 up. And let's see how that plays out. We could plot our point at the vertex, -2, 2. There it is. This is obviously graphed on Desmos already. And from that point, we're going to go 1 over and only halfway up. 1 over and only halfway up. And guess what? We are right there on the parabola. And then we could go back to the vertex and go 2 over, and instead of 4 up, 2 up. So 2 over and 1, 2. And guess what? We are right there, right on that parabola. And last but not least, 3 over. And instead of 9 up, it's 4.5 up. So 3 over, 1, 2, 3. 1, 2, 3, 4 and a half way up. So you'd be right there at that location. You map that over to the other side of your axis of symmetry, and you'll be able to graph it all perfectly on your paper if you were graphing on paper like that. Alrighty, guys. I hope this makes sense. I hope this helps. It's too long of a video. I apologize.